Hello guys. Today we are going to solve a problem which is given by this grammar and where our sentence is a plus b star c. So if you review this grammar, the transformation rules are e goes to e plus e goes to e star e goes to open bracket, e close bracket and e goes to id. And where our sentence is a plus b star c, where a plus b is in bracket. So first of all, we will check whether our grammar is unambiguous or ambiguous. Now, for any grammar to be ambiguous, it will have two solutions to a given sentence. Now, for example, we'll take a sentence id and plus id. Now, if you see the past tree for that, we'll start with e and we'll apply any one of the transformations. Let us say we apply e plus e. Now, if we apply e plus e, we'll get e plus e. Now we can alter both these e, but we'll start from the left side. So since we need to get plus here, we'll apply the same recursion again and we'll get e plus e again. Now since these have to turn into IDs, we'll apply this transformation to get this and we'll also convert this to ID. So here we see our sentence is ID plus ID plus ID. Now as we can see in the second tree, which we'll draw right now, is that we start with e and we expand it to e plus e. In this tree, we'll apply this transformation to this e instead of this e and we'll get e plus e here. And if we convert all these to id, we'll see that we again get id plus id plus id. So we see that there are two ways to get the same sentence. Let us see another example to get the concept straight. So we'll see id plus id star id. So again we're going to start with e and we're going to separate out into e star e. Now since we're going to transform both these e separately, so this e will become e plus e by this transformation and then we'll convert this to id. After that we're going to convert this e to id too. So our final sentence is id plus id star id. So as we see, this is the same sentence as this. Now we'll try to achieve this through another pass tree. So let us start with e again, but this time since I have a plus here, I'll apply this transformation to get e plus e, this transformation rule. So we'll, instead of breaking this e this time, the left side e, we're gonna break the right side e and write it into e star e because we need a star here. So we're using this transformation. Now we're gonna convert all these e's to id, like e goes to id, e goes to id, and this e goes to id, and we again get id plus id star id, which is the same as id plus id star id, which is our required string. So this again proves that our grammar is unambiguous. Now to really understand the concept, we'll try to again understand by another example how the grammar is ambiguous. So let us take another complicated example which is actually similar to our string, that is id plus id in brackets star id. So this will actually help us understand how this sentence will behave in our parsing and stuff. So again we'll draw the tree e, we start with e and we break it into e star e. Now since we have a bracket here, we'll have to use some other transformation. Now, since we look for a bracket transformation here and we see e goes to bracket e. Now, this transformation will go here and then we're going to try and reduce it to this one. Now, as we see, we can go from this e to e plus e. So, we'll use the transformation to go to id and then we'll convert this e into id. So, our final sentence is bracket id plus id bracket star id. So, in the end, we get we get the sentence which we require, but as we will see that there are two ways to get this. We'll start with e again and we'll go to e star e and apply the transformations again which are given here. We'll apply e goes to e bracket, e goes to e star e, and we'll also apply the id for e. So in the end we get bracket id plus id bracket star id. So as we can see, we get the same string again. So this clearly proves that our grammar is ambiguous and it is not
SLR1 table for the following grammar. SLR1 is basically it takes one input with the parse table. So first we need to find the follow and first of it, which was explained previously. Wait. Okay, so first we have 9 different states for this table: I0, I1, I2, I3, I4, I5, I6, I7, I8, I9. So first we see that I dash gives E dash gives dot E, So first we take E as the argument. So first, since this is E dash gives dot E, the dot will be moving this side. So we know that the parser has read the variable. So according to that, we get I1 in with the first and the follow will be according to the E, that is plus star and open bracket and ID. For the following, it will be also be the same. Next, we apply I2, that is open bracket. We take the grammar E gives open bracket E close bracket. So op- we get the following rules, and these are the following first and the follows according to the argument given after the parser reads the variable. In the same way, we get I3, that is we use the grammar E gives ID. Since it has only one variable, so we can declare it as the final state. And then we got I2 to I1 since we have unfinished readings in from the variables. So we get I4, that is when we apply plus. So this dot will move across the plus sign since it is reading plus. And since there is E, we again write all the grammars of E with the starting symbols as a dot dot here. And then let us see this first. Since the dot is E, so we again apply E and we finish the first statement. That is, the parser has completely read the first statement. And since it is finished, since we have other statements containing E, so we will also solve these. So this dot E will move here. So we get E dot plus E. And then again for the third argument, we get E dot star E. And since to complete these both, we apply once more dot so that the plus moves here. So we get I4 again, which we already got here. So we are not writing it again. And star, we get I5. And so now we come to I5. Since in I1 we have E dot star E, now we have to finish, now we have to insert the variable E. So when the parser reads E, we get these followings. E star dot E, then again we have E, so we will repeat the whole grammar which we have been given here. And we will write the first and follow accordingly. Then since here dot E is left, so we will again input E and then we again get the same as I7, and I8 and I7 are mostly same, so it will be conflicting in the following table which I will be explaining later. And now we come to I6. I6 is this one when we apply E here, since we have this E as is not been read till now. So when we apply that, we get E dot E open bracket E dot close bracket, and the first of that will be ID. And then we since we have other expressions also, so we'll write it again, and the first and the follow will be written accordingly to it. And to complete this, we will again, since in the first expression we have a close bracket, we apply close bracket here to complete the expression. So we get this I9, which will be the final state. And then we get plus and star to get I4 and I5 again. So here we see that since the grammar is unambiguous right now, so there are a lot of things repeated which will be explained in the SLR table. Now we come to the SLR table. To create the SLR table, it is same like LR0, LR1, LALR, CLR table. So first we write the non-terminals at the last, terminals in the beginning with dollar sign separating it. And we have to know that the dollar sign will have the accept symbol so that it accepts the language. That is A plus B star C in my case. And then the terms we write here, that is if like from first we write the all the 9 states here, I0, I1 till I9. And then from 0 we will I0 we will see that if something that gives ID, where does it go? So it goes to I3, that is in IO. If we input ID, it goes to I3. So what we will write is we will write it S3. And then we again see that where are the inputs. So we get I0 to I2 via open bracket, so we write open bracket S2 as here, and from I0 to S2, so here. And then we go to I1. From I1 we get plus, we put star to I4, so it will be S4 here. And then we do it accordingly, so we get all the tables as S3, S2, S3, S3, since ID goes to from I0, ID goes to all these places. Then using I1, we go to I4 via plus symbol here, and same as I5, we go using a star symbol here. Then that's it from I1. Then we come to I3, that is our final state. So nothing here. There are no S in here. Then we go to I4. I4 we have E. We go to I7, so we write 7 here. Then from I5 we go to via E to 8, so we write 8 here. Since it is a non-terminal, we write one the state, the number of the state, that is 1678. That is I7, I8, I6, and I1. And for the remaining terminals, we write S3, S4 according to the values. And now this was the conflicts. There are some conflicts here since the first and the follow matches, and since like I7 and I8 are the same tables. So what we do is first we find the conflicts, and like here we can see from I7 we have conflict with plus and star since both goes to I4 and I5. Here also I4 and I5. So we write here R4, R5, R4, R5. And since in I9 also we get R3, R3 because the grammar is 1 2 3 4, that is we if we number it then we will get 1 2 3 4 5. So for I9, that is here, we get a plus and a star, so we go, that is we are using the third expression, that is this one. So we get a plus, we get a star. So we write R3, R3 here. In the same way we write R4, R4 here following the fourth expression. And now we can see that here there is a box, that is the conflicted area where I7, I8 are same because both contain same values. Hence we say it is an RR SR conflict. Hence the table is like SLR parser cannot compile this grammar, that is E gives E plus E, E star E, open bracket, close bracket E, and ID.
Storage organization. It means how data is stored in PC and how compiler reads it from the memory register. So runtime consists of generator code and data object, and it has two types: static and dynamic. Static, it's stored in static area, and dynamic, stored in heap. Stack to keep track of all the procedure activities. Procedure for call sequence status is saved in on the stack here on the stack. Call procedure execute and returns. Register values and PC are stored in stack here. So stack organization, uh, high and upper is high and lower is low. As procedure is called stack grow downwards. As dynamic store is called allocated heap grows upward. So next we come on activities records. Activation records. It store info needed to execute a procedure. AR is pushed when procedure is called popped and when it returns. AR typically contains local data, machine status, actual parameter, return values, and storage allocation strategies. Uh, Static allocation is irrelevant to our procedure. Dynamic allocation, example C, Java, C++. Static allocation necessary for implementation function in ML. Special register top SP mark on the top stack. So here are the three of three four definition of call by value. It is easy, no special compiler efforts. The argument are evaluated at the time of the call, and the value parameter are copied and either behaves as constant values during the execution of the procedure. Call by reference. The argument must have allocated memory location. The compiler passes the address of the variable and the parameter becomes an alias for the argument. Local access to the parameter are returned into indirect access. Then we come call by value result. Argument are evaluated at call time and the value parameter are copied and are used as local variable. The final values of these variables are copied down to the location of the argument when procedure exists. And last one is call by name. Call by name. Whole different ball game. It keeps passing the text of the argument expression. Un, un, the text of the argument is viewed as in the function its own right. Also passes the environment, so free variable are still bound according to the rules of static copying. The argument is not evaluated until it is actual used inside its code. Thank you.